As we continue to look at probability and statistics, we're going to be looking at probability models in this lesson. Now, probability models are simulations or activities designed to show us the likely outcomes of a real-life situation. Now, when we design a probability model, or a game or a simulation, we have to follow a couple rules. So let's take a look at those. The first rule is that the game or simulation has to be fair. What this means is that all parties involved have an equal opportunity or equal chance of coming up as a possible solution. You can't do things in a specific order or one after another, because those at the end of the line don't stand the same chance as those at the beginning. So it has to be fair. Next, each player has to have the same probability of scoring a point. You can't do things that involve particularly physical skill, because different people have different physical abilities. Can't go off of things being higher or lower, because then height of the person comes into play. So everybody has to have a chance of scoring. And last would be that the results have to be random. So if you do a simulation or select people in one particular fashion and then run the simulation again, those people that were chosen before have an equal opportunity of being chosen again. Some people feel this is not fair, but if a game is truly random, then everybody always has the same likelihood of coming up as a result. So how are we going to look at, or how do you design things that are random? One way is to use our common items that we have for selecting. You can use dice, you can use random numbers, you can use cards in a deck, anything that completely randomizes the situation. If people are to be chosen, two siblings are discussing how to go about choosing who gets to participate in a certain activity, they can't flip a coin because they can't flip at the same time. They can't roll a single die, again, because one might get the results before the other one has to ever be in the trial. So you have to go back and forth in such a way that things are equal opportunity. Let's take a look at some specific situations. One common way that is used for selecting items is to use random numbers. Pictured here is a random number generated chart. The numbers are from 0 to 9, and at each location a computer chooses a random number to fill that spot. They're put into groups of 5 simply to make it easier to read. And the way it works is typically you close your eyes, point to the table, and select a location to begin, such as this. Now this location, this 4, in the second grouping over, third row down, is where I would start for a simulation. So let's take that number and see what we can do with it. I'm going to start again with the number 4 located here. And what it went was 4, 1, since I covered that up with the writing. Now our situation. A history teacher wants to split 10 students from a class into 2 teams for a review game. He begins by assigning each student in the class a number from 0 to 9. How can you use the random number chart to fairly assign teams, and who will be on team 1? So everybody has a random number, 0 through 9, and then we're going to begin by developing the teams. Once a number is used, that number is no longer in play. So we're going to build the teams until we have all numbers 0 through 9 represented. Team 1 gets 4. Team 2 gets 1. The next 1 has already been taken. So then Team 1 gets 6. Team 2 gets 2. Team 3, the next number is a 4, that's already been used, so team 1 will get the 3. Then our next number is a 1, but that's already been used, so we'll come to 8. Next is a 3, that's already been used, so team number 1 gets 7. The 1's been used, but the 0 has not, so Team 2 gets player 0. The 3's have both been used, as has the 4. Next up is this 9, so Team 1 gets player 9, and the only number that would be left is number 5. So Team 1 will consist of student numbers 4, 6, 3, 7, and 9, and Team 2 will be students 1, 2, 8, 0, and 5. If you're using numbers, or if you have a situation where it's more than 10 individuals, like let's say there's 16 in the class, and you want to assign them out into 2 teams, you can number them from 0, 1 through 1, 6. And then you only take numbers that coincide with that. For instance, if we were to use the first row, the first number that we'd effectively be able to use is 0, 7. And then you'd have 0, 5, 0, 4, 1, 2, jumping between those two numbers, and so on until you find everybody that you're looking for. So when you use a random number table, you have to kind of work around it somehow. If you're selecting items either as a yes or a no, you can assign 0 through 4 and 5 through 9, or odds and evens, anything that has an equal opportunity of showing up. But we also have other situations that we can use such items for. This situation is going to fall under the situation or the title of modeling a situation. So you buy a new board game and start reading the rules. You learn that you must roll a 4 to move your piece from the starting position, and you want to have an estimate of how many rolls it will take to do this. You are also using only a single die in the process. Describe a simulation you could use to predict the number of times you would expect to roll a fair die before you can move your piece from start. When we have a modeling situation, something that's going to take after what happens in real life, you don't run a simulation once. You develop a situation that has the same probability as what was occurring anyway, and then you run it a number of times and find the average. So in this situation, we're rolling a single die, and we have to roll a 4. So what we can do is set up a series of rules and then run it a number of times. So rule 1 is roll a die until a 4 is rolled and record the number of rolls. So what we're doing is we're saying I have to roll a die until 4 comes up, so let me roll until 4 comes up and just count how many times that takes. Each time you roll the die, it's independent of previous rolls. Second, run the simulation. A predetermined number of times. In this case, I'm just going to randomly say 20 times. And each time we're recording how many rolls it takes. The first roll could be a 4 one time. Another could take us 10 rolls to get that 4. However many it takes, we're going to record the number for all 20 trials. Then, number 3, average the results. So we take all the different number of rolls it took to get a 4 for each run of the simulation, and then at the end we add all those together and divide by 20 and say we come out with an average of 7.3 rolls. So that means it's going to take between 7 and 8 rolls to even get your player into the game in order to play this new board game. So with probability models, simulations, there's a number of different things that can be done. You just have to make sure that you're following the rules and when running a modeling situation, establish the rules before you begin.